Alright, hello YouTube, slash internet. Today I'm going to talk about a really fascinating idea that I recently had the privilege of reading about. And it's cosmological, it's about the universe as we know it. And the idea is called Ekpyrosis. And that word is of Greek origin. We have the Greek word, the ancient Greek word, Ekpyrosis, which means conflagration. So what ekpyrosis is, it's a theory that the universe is cyclic by nature. Um, and in physics and cosmology too, and both of those fields merge frequently when we get to the quantum and superstring theory aspects of both of those. Um, so, physics now has the Big Bang Theory. The Big Bang Theory states that there was a singularity. A singularity is a point where the fundamental laws of physics break down. So contemporary physics has the Big Bang Theory. It was a moment where all the density, all the mass of the universe was in one infinitesimal point, a singularity. And when that bang happened from the singularity, the universe as we know it happened. The universe expanded really fast, and the gases compress to form stars. Stars form matter that we see from stars. From the transmutation of gases, we get the fundamental elements that are responsible for the universe. So, with the Big Bang Theory, physicists have tacked on the inflationary cosmological theory to the Big Bang. So it's not really changing the Big Bang, it is adding to the Big Bang. Physicists say to account for observations we've made in the universe, the standard Big Bang wasn't going to cut it. So the inflationary model says that at the Big Bang, the expansion of the universe was actually far, far, far more accelerated than it is now. The universe is expanding. At one point, it was many times the speed of light, the expansion of the universe. It was inordinately hot at that time. And this expansion was just profound. It was fast, extremely accelerated. And then it slowed down. And what confuses physicists is that at some point, the expansion of the universe, instead of decelerating as it had been, it begins to accelerate again. And physicists don't understand the nature of the acceleration of the expansion of the universe, so they've attributed this to the presence of what they call dark energy. Dark energy is a force that causes expansion, and it's energy that drives matter away from other matter. It's like an expansive agent. So physicists now, in the observational universe, we're beginning to see some inconsistencies with sorry, I'm tired. How everything works. So our proof of that is cosmic radiation waves. These are radiation waves, and they're for the most part, they're evenly distributed across the universe. And this is proof that the universe was at one point exorbitantly hot, but it's proof of the Big Bang because this radiation level is uniform throughout the universe, with a few exceptions. There are a couple of fluctuations which are usually attributed to quantum mechanical fluctuations. So what this uniform radiation means is that it's proof of the fact that the universe expanded from the singularity, which explains the uniformity of the radiation. Blah, 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 blah. So, the inflationary model of the universe, because of the rapid acceleration of the expansion, it predicts gravity waves. And gravity waves were a theoretical concept that Einstein's theory of general relativity predicted. So at this point, they haven't been observed. Physicists are trying to understand gravity, gravitons, on a quantum level. Gravity is still kind of vague. But there's been a space probe out to detect for these gravity waves. It's going to come back in 2020. Around 2020, give or take. So if the gravity waves are there, that gives credence to the inflationary model. If there are no gravity waves, then it gives credence to Ekpyrosis. Ekpyrosis is interesting. This theory originates, its roots are in superstring theory. Superstring theory is a quantum physics theory that basically states it's used to conceptualize quantum particles. Quarks, leptons, bosons, all these very ambiguous quantum particles. Superstring theory is an incorporation of that. Superstring theory proposes that our universe has 10 dimensions. Humans observe 3 of those dimensions. Our observable empirical universe, as far as we can tell at this point in time, consists of 3 dimensions, add a 4th one for time, a temporal dimension. So, the theory of Ekpyrosis makes the bold claim that the universe is cyclic. Superstring theory says that our universe is a membrane. It's a membrane of the 10-dimensional omniverse. So, there are many. Superstring theory proposes that there are many of these membranes, 3-dimensional. Us down here on the 3rd dimension form one of these membranes. Now, theoretically, if another membrane were to make contact with this membrane, we would have a collision of titanic proportions. The reason for this is Einstein's famous equation, E equals mc squared. Energy, latent energy, is mass. Mass, energy. That's how the theory works. So, these membranes, the omniverse has gravitational forces too. So these membranes, when they collide, because there's so much latent energy in these 2 membranes, the collision that would start, it would be a conflagration. It would be equivalent to the Big Bang. However, Ekpyrosis states that this collision would happen when the universe was actually very vacuous and cool. The Big Bang says that it started out fiery and hellish. The membranes would collide in time intervals such that the universe, our brain, our membrane, is empty, virtually empty, not completely empty, but dark energy over billions and billions, trillions of years our universe at one point will be so sparse that it will be effectively empty. Not completely, that's impossible, but effectively empty. These two membranes collide, and the Big Bang is sparked. And so what happens then is what we observe. It's pretty simple, but it's just a really interesting way to look at it. It changes the way you see reality, that we're one membrane in an omniverse of 10 dimensions, and that it's cyclic. You know, this theory really shatters the idea that our universe is it, that there's nothing outside of this universe. You know, this theory hasn't been proven. Many scientists have discern that the theory behind it is sound, but then again, theory and practical hard evidence are vastly different. They usually go hand in hand, and one needs the other, but just because it's theoretically sound does not mean it's true. However, the implications are very fascinating. Very, very fascinating. And really, the difference between inflationary cosmology and ekpyrosis would be that when you plug in the models, the mathematical equation of superstring theory, the minor fluctuations in the cosmic radiation that permeates throughout the universe are accounted for. So we don't need, you know, there would be no gravity waves. It would be explained by the collision. Superstring theory, okay, the membrane that we live on, think of our universe as a membrane. It's, of course, when it's populated with matter, you know, the membrane becomes sort of curved. It's not perfectly flat, so to speak, as a vacuous universe would be. So because of that, the collision causes these wrinkles. Mathematically, these wrinkles are accounted for in the cosmic radiation. So the enigma of, well, where are these cosmic fluctuations coming from? That is also accounted for by this theory. So ekpyrosis is fascinating in that the observational universe fits the ekpyrotic model so far perfectly. Has not been disproven. Hasn't been proven, hasn't been disproven. However, it's a very refreshing alternative to standard inflationary cosmology with much grander implications, because if we take the Copernican principle, which states that our position in time, our position, our circumstances are not special. You know, just like Copernicus said that we don't revolve around the sun, that we do revolve around the sun. You know, that what if, just like the sun might not be the only star, that we might not be the only planet with intelligent life. You know, at the same time, it's kind of ludicrous to me to assume that our universe is the only universe, that our 3 dimensions are the only 3 dimensions. It seems bizarre to me that we would be special, the one. So the ekpyrotic theory, superstring theory, seem very intuitive, despite the fact that theoretics behind these theories defy what we see in everyday life. So it's just something to think about. You know, I love cosmology, astronomy, space, and to me this merges with philosophy and understanding our place in reality, understanding reality itself. So I thought I'd share this with you. I hope it made sense. It's kind of hard to explain. Sometimes it's hard for me to understand. But it helps me to just explicate it to you guys and get you guys interested in it. The more scientists we have aboard, the more progress we will make. So that's all I've got. Thank you.